Mapping in Greenland is complex. In many cases, we are working on remote areas. There is nothing there. You are sometimes the first person walking on an area or describing a geological process, and that's the reason why we call expedition. Greenland is covered with a geological map at 1 to 500,000 scale. It gives an idea, but when you go in detail, as for instance, an exploration mining company, they need a detail up to 1 to 50,000 or 1 to 10,000, and that we don't have. A geological map, it is a map describing geological units. But the map itself, it is a combination. First of all, we produce a topographic map where you can see lakes, rivers, fjords, the coastline, the mountains. And once this is ready, we start to put the geology on it. That means we draw with a color pencil each geological unit, and that's the final product. What is difficult for externals to understand, it is the logistical part. When you approach a new area, you have to collect everything you can, because that is probably the last time you go there. The first things to do is to do ground truth by geologists that go for the rocks. All the teams are in the field, far away from base camp, and we stay there for 3, 4, 5 days, and after a while we get the contact with the base camp and we get a helicopter to pick us up and move to another place where we put the camp and we stay there. So in this way we visit many localities and we collect a lot of samples, usually tons of samples. Since the area is really big, we also use the helicopter to collect oblique photos of the mountains. And we have a system, it is called photogrammetry, that can be used for mapping when we are back in the office using 3D photogeology. Recently, we also started to apply another method. We have an external arm attached to the helicopter, and to this arm there is a box, and within the box there are 2 cameras, an RGB camera, a normal camera, and a hyperspectral camera. So when we fly with the helicopter, we plan to collect images from a specific area, and the RGB will collect a normal picture, while the hyperspectral we collect a specific signal from the rocks that can tell you something about the mineralogy of the rock.
I use hyperspectral remote sensing to help geologists with their work. The main thing that we do here at GEUS is that we combine this type of data with photogrammetry data. In photogrammetry data, you have what we call a normal image, an RGB image, which basically shows you what you can see with your naked eyes. And with hyperspectral remote sensing, you can see beyond that.
Sarah, she's the expert. She's the one that collects the data in the field, and she's the one that processes the data. And I'm the one that receives the data and try to link those data with the geology.
Basically, each material on the ground has its own fingerprint, and then you can use that fingerprint to find those material or those targets that you're interested in. And not only to find them, but you can also say how much of that material you have in your image.
These things are jarosite, so yellow is jarosite and amphiboles are in green. The others are like this. Is usually the purple color is the background at this point.
We will take those data, those images, and overlay with the geology that we know. And we'll see if any of the mineralogical aspect on the hyperspectral images can be picked up on structures or specific rocks. We believe that providing a better geological understanding of an area can help exploration in Greenland. The aim of geological mapping is not only map production. We also want to do science. We want to understand the dynamic of a geological basin or a magmatic system, and we want to help exploration companies to focus on the exploration and not on geology. That's the core of the idea, and that's what we do.